So today I'm here to talk about breaking down some barriers around CI/CD. So we'll just dive straight in. So first and foremost, my complaint about the industry as it stands today. We're told many times that security is very important. You've all told me that security is very important, yet you still, you still keep sending me emails apologizing for leaking my data. You also tell me that it was a very sophisticated attack. It wasn't. It was just, Tony from accounts didn't read his emails properly, right? Phishing emails. So today, I think the important thing I want you to walk away with is that we actually need to be doing something about this now. We can't just keep pretending, right? It's getting serious. So who am I? My name is Bryan Ross. I'm a field CTO at GitLab. I have spent all of my career building platforms and helping businesses put things together. My boots are dirty, though. I spent 10 years at Sky TV doing this stuff for real, running large engineering teams, cross geographies, and all that good stuff. In my spare time, involved in various communities as well, including CNCF. My big thing really is trying to convince businesses that our problems, technical problems, are not technical. They're usually people-based, right? And we're going to see this in this slide. It's about people, process, and technology. So don't go running away trying to buy a product. We actually need to do some work behind it. So I won't lie, I put these slides together last night, and I was a little bit puzzled as to how I was going to talk about CI in a way that is borderline interesting at 4 o'clock at the end of a tech conference. So here we are with Scotch broth. It's really interesting. I'm stealing this idea from a guy called Gareth from TechWorks AI, who was at the GitLab Connect last week. And he had a great presentation about SBOMs, which is Trusted AI Bill of Materials. And he talked about cans of soup and about provenance and trust. And so I'm just going to take his idea, steal it, and then extend it. I think that's what we do here, right? First and foremost, the things are changing around how we look at software. It's no longer just your code, it's now more of a product, right? And I think we need to be learning something from the food industry. So we've got the EU Product Liability Directive, which basically says you're going to be responsible for all the whoopsies in your software. That's probably bad. We've got DORA coming in as well, which is all around maintaining comprehensive supply chains and evidence as what's been going on. And all of these things indicate that we're becoming less interested about what's in the front of the can and a lot more interest in what's on the back of it. So if we think about a food safety incident, right? So say we've got a can of Scotch broth and there's something nasty that's ended up in it. Hopefully by accident, hopefully not maliciously. What happens? What do the regulators want to know? Well, immediately everyone jumps into action, right? We know every ingredient that's gone into the can. We know where those ingredients came from. We have agreements about how those ingredients are collected or put together. And in our factory, we've got standards and quality control. We can trace the can down to individual batches so we can work out what kind of message we put out there. Whereas in the software world, when we have, say, Log4j happen, we all just have a really bad weekend and then spend months trying to fix it, right? We need to do something drastically different. So your application isn't just code anymore. It's a really complex recipe that you're not even responsible for all the parts. But going forward, you are going to be responsible for those too. So what can we learn? Well, in my humble experience so far, I don't think that it's a lack of knowledge about what good looks like. I think we all generally know how to build secure software. The problem is we're not very good at doing it consistently across a large, complex organization. I've seen policy documents, security policies, explaining exactly how a company should operate. And then I talk to individual developer teams and DevOps teams and find out that they're implementing some of it, but not all of it. And it's never the same sets that people are covering. It's always something else. One team is really good at this, another team is really good at that. So we need to really think about how we get consistency in the way that we process things. Thinking like a factory rather than the kind of artisanal soup creators, right? We want to be doing this at scale and building all of good practices in. So we're pointing out a couple of things that are maybe important. In a factory, What are some of the key things that you think of when you think about a factory environment? First one's going to be hygiene, right? Or certainly you hope so. We don't really have that in IT. We're kind of messy sometimes. We don't store things where they're meant to be stored. We don't follow process all the time. I'm not going to talk about what you write in a commit box when you put a merge request or a pull request through, right? I'll leave you alone. But we all know that you're not doing good enough. We think about, as well, about the repeatability and what happens when a mistake happens. In a factory, quality has to be followed, otherwise the conveyor belt stops. And everyone knows they need to play a part in making sure that we keep a sustained consistency in the quality. And if we don't, bad things happen. Again, we're not very good at that in IT just now, and I think we need to change that. So in a factory, the conveyor belt doesn't move unless the quality checks pass. The ingredients tracking is all automatic. There's not someone there with a clipboard going, all right, how much carrot are we putting in this time? Like, we know what's going in, right? And we know where it's come from. And the sanitization and the hygiene is happening every day on a schedule. It's part of what we do. We're not waiting until we've had a problem and going, oh, well, what else have we got hidden in this cupboard, right? So how do we go about building a factory? Fundamentally, it is people, process, and technology. Factory doesn't be great because it's got lots of robots. It's there because we've got a good mix of people, good mix of process, and maybe some robots. It's about getting the right people working together harmoniously. It's about having a standardized or normalized process, and then using technology to build compliance in and traceability so that we can get all the way back to batch numbers. So, not a sales pitch, but obviously GitLab. So kind of what we're doing at GitLab is to try and bring everyone together into one environment. So, you know, if you think about making soups, it's about trying to figure out how we can get everyone following the same processes, even though they might be using different ingredients or have different requirements. It's about giving developers some guardrails that need to fit in between without impacting them too much around particular tool choices, etc. So all of this is around kind of value stream mindset. What we're looking at is how well can we get through this process and how do we work better together. And you'll see some big things here, like scanning for security, kind of obvious. Approvals, like we don't want them to be hidden away, we want them to be out in the open. We want to see transparency. We want to get people commenting on them, right? And then the review stage needs to go back in. The nice thing about getting everything together into one system is it means from a people perspective, we're all working together. We've not got different dashboards. Security can see what developers are doing. Developers get feedback from security. And finance are there going, does this all make sense, right? We need to be working together. Every commit, every scan, every approval, every release candidate, every deployment, all of it is tracked. And that's kind of critical if we think about how we go about dealing with a hygiene issue, because we've got these batch numbers, we know where things came from. So really quickly, I'm going to run through some of the things that I think we need to be implementing at a company perspective. This is based on my experience from GitLab, but it'll be applicable to pretty much any software. In terms of policy management, we need to be thinking about how we map our organization to the roles and permissions within the application. And that's not always easy. It's not always a clean mix. But if we get that wrong, we're going to have trouble later on, right? So we need to be thinking about how we're going to automatically assign roles, maybe based on your AD or some other system you're using for identity. We need to be thinking as well about how we go about attaching our compliance to some of those groups. So if you are a such and such, then you need to be doing these steps in your build. Whereas if you're somebody else, you might have something else that needs to happen. But again, we can automate all that if we do a little bit of thinking up front. Access controls, obviously fairly obvious. We need to be thinking about who's got access to all of this stuff. Like a factory line is a secure environment. Nobody can walk in off the street and add items into the mix, right? Our build systems need to be secured too. They're not just internal systems that are running and don't need to be behind firewalls. Build systems are critical. If your supply chain is affected, then production is already toast, right? And we're learning from some of the more recent attacks that supply chain is harder to fix long term. Other things that work from a CI perspective is things like having a common branching methodology. I would personally prefer you did trunk-based branching, but I know that some people find that really hard. I would say that doing trunk-based will help you in the long term. but it does involve you thinking about how you go about managing that. What it means is all your code modifications are in place, much easier to manage. Workflow automation is probably where the most interesting stuff happens. Separation of duties is really important. Should developers be able to see all code in your organization? On one side, that's a really good thing because they can now work collaboratively. But if their account is hacked, now a hacker has access to all of your source code. That's maybe not a great idea, right? Likewise, someone in security, should they see the code too or not? It's decisions to be made. We want to build reuse. What we're trying to achieve out of all of the workflow automation is building the kind of reusable parts of this. So in GitLab, we use compliance frameworks, and that is all about enforcing this idea that software has to go through QA, it has to go through security testing, and it will not go to production unless certain levels are passed. There's no point in you building those into a template project if a developer can then change the CI pipeline to remove those checks. I can tell you this because I've seen it for real. They need to be enforced. There needs to be some system there behind the scenes that's making sure they happen every single time. No exceptions. I think what we're trying to get to is be like the factory. When an auditor comes and asks us, is this secure? We're not having to stop and gather evidence. Like, our ability to show that what we're building is good is built into our processes. And we don't need to stop production as a result. We're not proving the product. We're not looking at what's inside one can. We're looking at the entire process about how these cans were all put together. And of course, audit management. The only thing I want to say about that is there is a big difference between auditability and traceability. So auditability is just making sure you've got logs. I'd like you to try and build traceability into your systems. In other words, thinking about what evidence you're going to need, either positive, to show that it's secure, or if you've attacked in some way, demonstrate what's happened, or you know exactly where it's happened, right? So traceability is going to be a key part. That's me whizzed through a lot of slides in a Scottish accent, so well done, everybody. Very quickly, I've talked a lot about CI on this. We've got the glorious and beautiful Stefan here to talk about Flux and what's happening there, because I think CI and CD are subtly different challenges. And so I think if we hear now, what happens once we've got this can, how do we then ship that safely out to the world, right? Stefan, all yours.
Thank you. Okay, let me tell you how we ship the can. Okay, so I'm Stefan. I'm a long-time Flux maintainer. I'm fortunate enough to be working full-time as an open source maintainer for 8 years now. I feel very fortunate around this, and yeah, today I'll try to explain how we ship cans in a safest way possible with Flux CD. So we started here, like, I don't know, 8 years ago, before Flux was the thing, before no one knew about GitOps, and this is, the classical way of delivering to Kubernetes. Like, this is what you probably did with Jenkins, with many CI tools out there. You have this all-in-one monolith. You store everything in your Git repo, your source code, your manifest, your Docker files, bash scripts on top of bash scripts. And once you change something, no matter where it is, right, you build everything. Hopefully you test everything. Then you connect to a cluster and you deploy it, right? What's wrong with this approach? Anyone? Any ideas? Okay, you are very shy. So from a security perspective, it means that your CI/CD platform has access to everything, right? Has access to your source code, has access to your package manager. In this case, it's a Docker and a container registry. It also has access to your production system. So what makes CI/CD platform now the single point of failure, the single point of attack of your whole infrastructure? We usually look at our production systems as running Kubernetes in production is in my VPC, it's in my dedicated AWS account maybe, or whatever, right? So we are building all these gates around our production system, while we allow our CI/CD system to connect to the cluster admin role, because I need to create a namespace, I need to deploy my app in that namespace, and so on, right? So how we can improve this bit? We break up the things. Break up are sad usually, but in this case, CI and CD are better separate than together. How we do that? CI role ends at pushing the container image. Of course, here you should be doing testing, you should be doing signing, you should be generating SBOMs, and everything that's fancy today, and everything ends up at the container registry. So all of a sudden, our CI platform no longer knows about our production systems, no longer knows about Kubernetes. Maybe not even that, right? Only knows how to build a container. Then we make the clusters, aware of the desired state which sits somewhere. And in the case of GitOps, the desired state can live in a dedicated repo or can be distributed across many repositories based on, what your organization needs. If you have many teams, maybe each team gets its own dedicated repo and so on. But the major idea of GitOps and the mindset, the shift in mindset, is that the production system takes its state. You don't tell the production system how it should look, what it should do, right? So one big advantage of doing this, obviously, is that you no longer have to expose your Kubernetes API outside your private VPC, for example, right? Your CI system no longer has to connect to it. Another big advantage of this approach, and especially if you are using Flux, is that it automatically scales horizontally. Flux is made to be run on each cluster. It's very lightweight. It has no UI, so you don't have to expose it outside the cluster. It sits there. It expands the Kubernetes API to reach out to outside and decide how the cluster should look like, what applications should be deployed, what versions, and so on. So if you add a new cluster to your production system, that cluster automatically knows how to take its new configuration, bootstrap itself, and so on, right? If there is here no single point of failure, but still there is one point of failure, is the Git repo itself, right? If the Git repo goes down, the Git server, then the clusters will not be able to, see their new state. But Flux, for example, has various components. One is called source controller, which it's responsible for connecting to your external sources and caching the last desired state inside the cluster. So you have some kind of resilience here. Also, if the Git repo, Git server goes down for, I don't know, half an hour or something like that, doesn't mean the clusters are out of sync. What Flux will be doing will say, okay, I cannot get the new version of the desired state, so I'm going to do the best of preserving the current version. So if someone goes on the production cluster, does a kubectl edit, and adds something to an application, or does kubectl delete some namespace, even if the fleet repo, the desired state is down, Flux will detect that kind of drift and it will restore everything that was modified, will undo all the changes, right? So it has, some built-in resilience by default, which, if we go back to the CI/CD monolith, that has no kind of idea of a reconciliation, right? You push something, the GitLab runner starts, applies it, then it's done. If you change the production system and you don't make any change in your repo, the GitLab runner will not run, Jenkins will not run. So no one knows that the production system now has drifted from the desired state. For example, someone injects a malicious sidecar into your production deployment. You'll have no idea. You need a bunch of monitoring to figure that stuff out. Flux can actually enforce it. And that's the magic of GitOps, because it also comes with resilience and enforcing that the desired state is actually what you know from your, what you have defined in your sources. So this is how the desired state looks like, right? It's made out of your Git repos when you have Kubernetes configs. Then you run Flux on all your clusters. But there is not everything is in Git. Desired state here is split into two different storages. One is Git, where you have your Kubernetes YAMLs, your Helm charts, and so on, but also your container registry is desired state. That's where you have, you know, the binaries wrapped in containers, the actual applications that are running on the cluster. So saying that you are applying GitOps and Git is the whole desired state is kind of a false, statement. It's half true, because the other half is in your container registry. So what we've been doing in Flux for 3 years now, we are moving in a different direction away from Git. And what Flux currently supports today is this type of delivery architecture, which we call it Gitless GitOps. It feels silly, but it is what it is. Right, so what's happening here? We are trying to unify the desired state under a single storage. And the storage that we choose to do it is the container registry. Why? Container registries are already there, present, next to every Kubernetes cluster you have. Otherwise, you'll not be able to deploy anything, right? All your apps are there. What that means is that container registries, if you are in a regulated environment, are already confirmed, are already there approved, right? If you, let's say you are a financial institution and you want to adopt GitOps today, you have your container registry in there, that's approved. You have your Kubernetes cluster, that's approved. But to do GitOps, that means the Git server now becomes part of your production system. You have to approve that as well. The Git server becomes a production concern, 100%, because, well, the production cluster connects to the Git server. So it comes with a lot of challenges. So what we've seen years ago when GitOps started with Flux and then with Argo, Jenkins X, and other projects that are now quite dead, two winners are around. What we've seen back then was that, financial institutions didn't quite jump on the GitOps boat right away. And the problem was, well, the Git server now has to be in my production box. And that's hard for me to do it. I need to spend money, I need to invest, I need to have SRE teams that have to, SLAs on the Git server, while the Git server usually is seen as a concern of the dev lifecycle, not the production and operation lifecycle. So our solution 3 years ago in Flux version 2 was to come up with a OCI artifact type, which is specific to CNCF Flux. We have registered this OCI artifact type. The Flux CLI has quite the same commands as the Docker CLI, so you can do Flux push my configuration in the same way that you do Docker push. Then you can sign this artifact in the same way you would sign your container registries. You can attach attestations to it. You can attach provenience and all of that stuff. And then Flux on the cluster side can verify the signature, can verify that whatever config you have in your container registry and are telling your production cluster, now you need to move to this new version, you need to deploy all these new apps, Flux can actually verify. Is the new desired state signed? Is it signed by an actor that was approved by the platform teams or whoever has set up the production cluster? And it works with cosign, it works with notary, it works with cosign and OEDC. You can this so-called keyless signing when you use an OEDC provider in your CI system to sign the artifacts. Then Flux on the server side can actually verify, okay, this comes from an approved workflow, and so on. For example, a GitLab runner can run with OEDC, right? And it can sign all the artifacts with an identity, right? So you then will tell Flux, hey, trust this identity. And you can do the same thing for your container images. You should do it already, right? So there are so many solutions out there in CNCF that allows you to say, oh, I'm pulling a new image, you need to verify it, you need to verify the signature and so on. And you can do the same stuff with Flux. So basically what we are trying to do here is unifying configuration, app code, and binaries along with attestations, SBOMs, and everything under a single storage, under a single solution. So you may ask, like, okay, but I'm kind of losing a bunch of advantages of GitOps, right? Like, what about traceability? How do you figure out stuff? Like, I'm committing something to Git, and then in the cluster is no longer deployed from Git. How can I look at the cluster and see where is this coming from? So how we solve this? The Flux push command, the CLI, adds to the OCI artifact a trace of the Git repo, branch, SHA, all the things, all the metadata that allows then you on the cluster to write the command flux trace this pod or flux trace this deployment. And Flux will be able to tell you, oh, this deployment comes from this OCI artifact stored in this container registry, which is signed like this, but that artifact was produced from this Git repo, from this branch, at this Git SHA, right? So if you adopt this GitOps solution, you are not losing traceability. You actually know where to go and fix the stuff that's broken in production. So moving to this, you have basically the same advantages of connecting your clusters to Git. You are still doing GitOps. Your infrastructure people and dev people are still collaborating through merge requests through Git, but your clusters no longer have to go there. They go to the container registry. And over the years, we've seen major institutions adopting and major organizations adopting Flux OCI artifacts. The latest adopter is the Royal Bank of Canada. I think 2 weeks ago, they published a use case on CNCF, on the CNCF website where they gave some details of how they are using Flux, how they are using Flux OCI artifacts, and why this, for them, was the right solution. And I just copy-pasted some of their, learnings, what they have achieved by doing this with Flux. And you see the second one, right? Enforce consistency by using OCI as a single source of truth. And I think that's one of the, it's a compelling reason for high regulated industries to look at this approach and try it, because I think it will simplify workflows and it will simplify the way your system gets audited. You have the audit trace in Git, because that's the idea of GitOps. Everything that changes in your cluster, you can do a Git history and see everything there. But you also have the advantages of everything is signed, everything can be verified, and everything can be inspected in a system which is not Git. Git is very hard to actually do inspection on it, right? Git has its own file system. There is a .git database. There are so many things in there. So if you want to build automation to look at how things are actually happening, interacting with Git, from my experience after years of working with Git from a programmatic perspective, I'm telling you, it's hard. While working with a container registry, doing a Flux pull command or using any other tools that you already have, because it's just an OCI artifact that contains files in there, is way, way easier. So you can do things like drift detection outside of the cluster, diffing to OCI artifacts between them is like diffing to files, whatever. And you can do all these operations without having to mess with Git as a protocol and with Git as a tool, which we developers, some of us love Git just because we are in this married situation with Git and there is no alternative. But no one actually loves programming against the Git APIs. So OCI also helps here. Do I still have time? 2 more minutes, okay. One last thing, like there is no talk without AI these days, right? So, yeah, MCP is big, right? Everybody's building an MCP server. Like it got out there, and all of a sudden, all the APIs will come with an MCP server, right? All the Kubernetes add-ons will have a server. Everything that used to be an API will be an MCP server. And Flux is no different. We have an MCP server. And building the MCP server was a fun experience. Using it was scary. So we had to build some guardrails around it. Was different between the normal MCP server that has access to all your data, like, I don't know, when you connect to your documents data store or whatever. The advantages of the Flux MCP server and most things that look at Kubernetes is that you can make the MCP server behave under Kubernetes RBAC, right? So when you build MCP servers for Kubernetes, you already have, a way of building restrictions around it and so on. We went a little bit more. We did more than just, have the Flux MCP server subscribe to RBAC. We also enabled a read-only flag. So no matter the RBAC that you have set, you can always say, I don't want the AI to do any kind of alterations on my cluster. And even if you enable write mode, so you can, let's say, use the Flux MCP server to debug a production system and let the AI fix it for you, if you are adventurous enough. Even then, we've built into the MCP server guardrails, and if it tries to modify an object which is managed by Flux, by default it will be rejected and it will tell you, hey, you are now trying to modify an object that's defined in Git or is defined in the OCI repo. Are you really sure you want to do that? Then you can say, yes, force, I'm going to let the AI do whatever, right? So there are some guardrails that we build around that. What's really fun, and I found it like it has tremendous advantages of using the MCP server for Kubernetes, is that current models like Claude 4, Gemini 2.5, the new OpenAI stuff, they actually know very, very well Kubernetes. They actually know very, very well Flux. They know all the APIs of Flux, how Flux works, all the relationships, all the Flux documentation is part of the Claude 4 training, for example. It knows everything. So if you, for example, in this use case, I'm using Cursor or whatever AI tool to work on a new feature of my app. I commit the code to GitLab. Flux Operator, which is an open source project built on top of Flux by ControlPlane, has this way of listening to events in GitLab or GitHub, Azure DevOps, and it can create a preview of my app directly from the pull request, right? So you can modify some code, you commit it, then your app, against with the configuration, is deployed on an ephemeral cluster or some preview cluster, and that's where you can inspect how is my app, the new version, without actually merging the pull requests, how is that running. I can run end-to-end tests and so on. But with the MCP server, you can actually use AI to, inspect the preview and, run all sorts of interesting things. Is my app running okay? How much memory it uses? You can tell it to run tests and so on. So from that perspective, where you use AI early on in the development cycle on the Kubernetes cluster, is an interesting use case and a safe one, I would say, because you're not running, you are not modifying production systems here. You are modifying a dev cluster, an app preview, and it's very good at detecting faults in the new version. Especially, we wrote some system prompts for debugging Flux configuration, Kubernetes configuration. And if you use our system prompts, you'll see that in a matter of minutes, the Flux MCP server can find real issues, and it will also tell you how to fix them. I mean, you shouldn't blindly trust what it actually tells you, but I think it's a great way to speed up, this churn of I'm modifying some code or some configuration. Will it work? Does it work? How it works? You can use the MCP server for that. And for production systems, it's really great during incidents. I suggest, if you are using the Flux MCP server, to enable read-only mode and have good role bindings around it. Okay, that was me. Bryan, any questions? I think we are done. We can take them after the talk. Thank you very much.